For the past few weeks, we've been working on graphing systems. Remember, when we're graphing a system, what we're looking for is an x and a y value that makes two or more of the equations true statements, which the x and y value are solutions to all the equations. So today what we're going to talk about is different types of solutions, special types of solutions. But the way we solve our systems isn't any different from what we've worked on in the past. Graphing, substitution, and elimination. So if we look at this example here, we have y equals 4x plus 2, y equals x plus 2. There's our system, our two equations. And we're looking for the x and y value that make both of these equations true statements. An x and y value that is a solution to both of these. Obviously there's a graph up here, so you know we're going to graph it. But also, when you look at these two, you should see that they kind of fall into slope-intercept form. And that's a hint, sometimes when they're in slope-intercept form, that you're going to want to graph them or probably use substitution. So since the graph's here, let's just graph these. We know our y-intercept for this first one is 2, and so I'm going to make this one blue here. So I'm going to go to my y-axis at 2 and plot a point. My slope is the coefficient of x. I'm going to write as 4 over 1 because we rise 4, run 1. So from our y-intercept we're going to go up 4, 1, 2, 3, 4, and over 1. And we're going to draw a line through there. Now remember, if you need to, you can always pretend these are both negative and go down 4, 1, 2, 3, 4, and to the left 1. And you could do that a few times. Okay, since if I kept going up, I would go off the graph. So this line represents all of the x and y values that are solutions to the first equation. Now we can take our second equation here, y equals x plus 2, and I will do this line in red. And let's draw a line that represents all the solutions to this equation. So our y-intercept is 2. Our slope is 1. So we will rise 1, run 1. And keep doing that a few times. And then draw a line that represents all the solutions to that equation. Okay, and what you'll notice is that where the lines intersect is our solution. And they intersect right there at the point 0, 2. So what we're saying is our solution of this system is the ordered pair 0, 2. Is the x value 0, the y value 2. So let's see if that works. And I'll show you what I mean here. We want to check our solution. We take our first equation here and plug in these x and y values. What we're basically saying is that y equals 2, so we're saying 2 should be equal to 4 times my x value of 0 plus 2. Well, 4 times 0 is 0, 0 plus 2 is 2. So it definitely is a solution to this first one. Let's try the second equation. Again, I'm going to substitute my values in, and I'm going to get 2 equals 0 plus 2. Is that true? And yes, it is. 2 does equal 2. So the solution of this system is the x value 0, the y value 2. And again, it's where the lines intersect. What we know about systems and the number of solutions basically is when the graphs of two linear equations have exactly one point of intersection, the related system has exactly one solution. And that's what this is right here, one solution. It is also possible for a linear system to have no solution or infinitely many solutions. And we've run into this in the past when we were just working on solving one equation, looking for a value of a variable. It was possible for there not to be a solution, or there's possible for every number to be a solution. And that's going to be true of systems as well. So let's look at one more example here. Obviously, these are in slope-intercept form. We're going to graph them. So let's look at this first equation here. Y equals negative 5/4 x plus 1. So my y-intercept is 1. My slope is going to be a negative 5/4. Now I just moved the negative up. You could have moved it down, it doesn't matter. But I'm going to go down 5. 1, 2, 3, 4. Oops. 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. Okay, and again, draw a line through these points. Now I will graph my second equation here. My y-intercept is 3. Sorry, I'm going to fix this line here a little bit. And my slope again is going to be a negative 5, 4. So I'm going to go down 5. 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. And what we notice is that we basically have two parallel lines. And what do we know is true about parallel lines? Well, that they're going to go on forever but never intersect each other. Now if we look at this right here, our solution was where the lines intersected. These two are never going to touch each other. So basically there's never going to be a solution. When we're dealing with parallel lines, there is no solution. There is no x or y value that is going to make both of these equations true. Now we can see that from graphing. Let's take a look at one more example. Here we have the system 2x minus 2y, I'm going to make that plus a negative 2y equals 8, and negative 10x plus 10y equals negative 10. Looking at this, I think the best way to solve this would be to do elimination, because I see if I just take this top equation here and I multiply it by 5, I have a negative 10x here. 5 times 2x would give me a positive 10x, and that would be opposites. So let's do that. I'm going to go 5 times 2x, which would be 10x, plus 5 times the negative 2y, which would be a negative 10y. And don't forget, go 5 times 8 to give us 40. And I'm going to combine that with our second equation here. So if I have 10x's and a negative 10x's, they cancel each other out. Negative 10y and a positive 10y cancel each other out. So basically on this side of my equal sign, I have 0. I have nothing. And if I combine 40 with the negative 10, I have 30. 0 equals 30. That's not true. 0 doesn't equal 30. So when you get something like this, that also means there's no solution. All of our variables canceled out, so we are left with 0 on this side and 30 on this side. 0 does not equal 30, therefore there's no solution. If we would go through and graph these, what we'd see is we'd have two parallel lines. So just like with when we solved for a variable, solved an equation for a variable earlier in the year, it's possible for there to be one solution, no solutions, and as you'll see in the next video, infinitely many solutions.